Hello class, and welcome to Conrad's Game of Life in Lisp. So to begin with, I'm going to talk about my overall goals for the project. Obviously what I wanted to do was create Conrad's Game of Life in Lisp. I thought that would be a good project to use for Common Lisp, and I thought it would be a good language that can accomplish this goal. But on a more personal level, I wanted to get a better understanding of core Lisp fundamentals, such as Lisp manipulation. Throughout this course, it's definitely been a challenge for me to really grasp the fundamentals and think in a way that a Lisper would, and just conceptualize problems and how to approach them. So I thought that this would be a good opportunity to kind of ground myself in the fundamentals and really get a good understanding of these mechanics that I just haven't had a chance to really fully understand throughout the course. And like I said before, I really wanted to learn how to conceptually tackle a problem in Lisp, because I think it's a mind game that I'm not used to with other coding languages. I think it goes in a different direction that I'm just not used to. So I thought this was a good way to tackle that problem. So going from there, I'm going to talk about the code. So we begin with game start. It's pretty clear. It just starts the game. It takes three parameters. Excuse me. Live list, which is a list of coordinates for live cells. Size square, which is the size of the squared grid. And number of generations, which is the number of generations you want to simulate in the game. This code, when you run it, it also creates the grid itself and passes that to the game recurse. Game recurse is the meat of the code and runs the game, generates it per generation. It checks for if the number of generations equals 0, and in that case it just returns the generation list of that last generation. But beyond that, it creates a bunch of local variables, manipulates the coordinates by generation, determining if cells are alive or will die by generation. It then draws the grid, sleeps for a little bit, and then recurses itself to the next generation, subtracting 1 from the generation number. Going on from there, we have getGridValues, which simply creates a two-dimensional list of coordinates based on the grid size. So it basically sets each coordinate to its own given value. Pretty straightforward with that. We have getNeighbors, which basically just looks at each individual cell and determines the neighbors for the corresponding cell. So all it does is add or subtract 1 from either the x or y coordinate of the given cell to get the 8 members around it, or less if it's on the border. Then we have getNumberAlive, which simply determines if the neighboring cells are alive or not, and creates generates a number value for that, and which is then passed to will live, which determines if any given cell will live or die based on Conrad's set rules, which state that if a given cell has less than 2 neighbors, it will die because of isolation. If it has 2 or 3, it will live. It's healthy, so it will continue to live on to the next generation. And if it has any more than 3 cells, it will die from overpopulation. And finally, we have the draw function, which simply draws each generation. It draws the grid itself. It sets values, so if the cell is alive, it's represented as an X. If it's dead, it's represented as a dash. And it also formats the cell so it stays within the X by X grid. So for instance, if you set the size squared equal to 5, you get a 5 by 5 grid, and you get 5 lines of 5. And that's pretty much it. So I will now run my code. I have you can put in anything you want, but I happen to find some patterns online and convert them to Common Lisp, so I will run one just to demonstrate that the code actually works. So as you can see, it will continually create and print the new generation up until the final num generation number you set, and it will keep going and creates a heart, creates a ship, does a bunch of, it just plays Conrad's Game of Life. This will go for a little bit. But as this goes, I'll talk about interesting challenges I faced. Definitely developing the game recurse logic was a headache in and of itself. It's something I struggled with throughout the course, so really figuring out how to get that to work conceptually was a very strong mental practice that took a lot of time to figure out, and a lot of back and forth between the functions and how the game is going to recurse, doing a lot of tweaking here and there, but I finally, as you can see, as it's demonstrating, got the code to function in a satisfactory manner, and I definitely feel like I learned a lot through that practice. Also, I initially wanted to do grid generation, as you see in most Conrad's Game of Life, where it just happens on one printed screen, but just the way that Lisp works and Common Lisp works, it's just not able to be done. So I just opted for the print of the grid for each generation. And those were pretty much it. Breaking down the project itself was pretty straightforward, just like what requirements I needed for each given function. That was pretty easy as far as that went, but figuring out the recursion was definitely a hard challenge that took me quite a bit of time to figure out. But I do believe I learned a lot from it. I definitely have a much stronger understanding of the core fundamentals of Lisp. Lisp manipulation, using built-in functions with Lisp. I've definitely had a lot of experience with using member, neighbors, whatnot, prog-n. Also, just thinking conceptually, I did a lot of going back to the book, Land of Lisp, and just re-looking at how he broke down, looking at a game and breaking it up into pieces, and it was a lot of back and forth with that. It took a lot of time, but I definitely think I have a much stronger understanding of Lisp in general and how to approach a problem in Lisp. And that's pretty much it. Thank you for your time, and hope you guys will post interesting questions. See you soon.